Section 8.2 talks about confidence intervals for means again, only this time we are not given the population standard deviation sigma. Okay, that makes this section a little more realistic than section 1 because, like I said before, there's not too many scenarios I can envision where we know the standard deviation but we don't know the mean. So when we are in this situation, we're going to switch distributions. Okay, we can only use the normal distribution if we know sigma. So if we don't know sigma, we switch to this student t distribution. And the reason it's called student t, just a quick history, there was a man named William Gossett who used to work for Guinness Brewery in, I think it's Scotland. And he was like a part-time amateur mathematician, and he developed this distribution, but Guinness Brewery had a clause in their employee contract that said that any discovery or development or anything that you created while working for Guinness belonged to Guinness. So he didn't really want to give his discovery away to Guinness Brewery, so he made it freely available to the whole world, but he did it under a pseudonym so that Guinness wouldn't know it was him. So he called it the student t distribution, and so that's still what we call it today. You'll see here that to find t, the formula is similar to what it was for z, only this time we don't have sigma, so instead we substitute in s, the sample standard deviation. Okay, the sample standard deviation is not quite as reliable as the population standard deviation, of course, so the t distribution has to be modified slightly. So if you look at this graph, the standard normal distribution is the blue curve, and it has the highest peak in the middle, and it has the lowest tails. The student t distribution actually changes based on the sample size, and you'll see that it typically has a lower peak, and it has a little bit more room in the tails, a little bit higher distribution in the tails. So what that does is it basically increases our margins of error by some amount and gives us a little more, gives us a little bit of a buffer so that we can have a little higher confidence in our intervals than we would without it. The student t distribution requires that we introduce a new concept called degrees of freedom. And to try to explain why degrees of freedom is n minus 1, imagine this scenario. Okay, imagine you're back in, or let's pretend for a moment that our class is an elementary school class, and if you do well, your teacher gives you stickers. So let's assume we have 20 students in our class, and I have 20 stickers, okay? And I'm going to choose who gets what sticker. So for the first student, I have 20 stickers to choose from, so I pick one and I give it to that student. And I go on down the list, and I only have 19 choices to make. Because for the first student through the 19th student, I have choices, right? When I only have 2 students left in the room, right? I get to the 19th student, I have 2 stickers to choose from, right? So at that point, I'm still making a choice. But then when I get to the last student, I don't have a choice anymore. I only have 1 sticker and 1 student, and so that sticker is no choice, right? It's just assigned to that student automatically. So basically what that means is I had 19 opportunities to make a choice because my sample size was 20. My population or my class or sticker sheet, whatever you want to think about it, I had 20 things and I had 19 choices to make. The very last one wasn't really a choice at all. I just had to give that student what was left. So that's the idea of degrees of freedom. Okay, if we have a sample of size n, then our degrees of freedom is always going to be n minus 1. And it's important that we know this because as you noticed on that last graph, the degrees of freedom change the shape of the student t distribution. Okay, the higher the degrees of freedom, the closer the student t distribution is to the normal distribution. The lower the degrees of freedom, the less it looks like the normal distribution. So if we're going to use the student t, we have to meet a couple of requirements. The first is we either have to have a normal distribution in the population, or we have to make sure that the population is only slightly skewed and that n is greater than 30. Okay, if we have a population that is very, very skewed, then the student t distribution is not appropriate no matter what. And in those events, if we don't have sigma, so we can't use the normal distribution, then we're just not going to be able to find a confidence interval. All right, so the formula for the margin of error, and I wrote this as E this time instead of EBM, because half the textbooks you read will just say E, half of them will say EBM, so just trying to keep you loose with the notation and flexible. So E is T alpha over 2, so that takes the place of Z alpha over 2 in our last section. So this is T alpha over 2, our critical value. We're going to multiply that by S, the sample standard deviation, divided by the square root of n. And then when we find our confidence intervals, we'll do the same thing we did in section 1. We'll take the mean minus the error and the mean plus the error, and that'll give us our confidence interval. When we're doing these in the calculator, we're going to use T interval instead of Z interval like we did last time. So everything else will be the same. You can use either data or you can use stats. You just need to make sure that you pick T interval when you don't have sigma. So for example 1, we have garlic is commonly considered to lower cholesterol. In a sample of 49 test subjects, changes in their level of cholesterol had a mean of 0.4 and a standard deviation of 21. Use these statistics to construct a 95% confidence interval for the change in cholesterol level. So we're going to use T interval. We're going to tell it stats because we were given the mean and the standard deviation and all that instead of given raw data. So we tell it stats. X bar is 0.4, Sx is 21, N is 49, and our confidence level is 0.95. That should give you a confidence interval of negative 5.632 to 6.4319. Now there's something important I want to point out here. It's not in the question for this example, but it's something you should think about. When you're asked about something like this, like the change in something, and you have a confidence interval that has a negative lower bound and a positive upper bound, that means that 0 is in that interval. And so one thing that you should consider is if 0 is in your confidence interval for something like, a change in cholesterol level or a change in weight or a change in scores or whatever, right? If you're wanting to see did something improve or did something deteriorate, you're looking for a change. If 0 is in the confidence interval, then there's a good chance that statistically speaking there was no change. Okay, so keep that in mind. A lot of times one of the key critical thinking steps here is to ascertain, is 0 in this confidence interval? Could that mean that there was no change in whatever's taking place? For example number 2, we have a similar problem, only this time we're given the data. Okay, so this is like seconds of alcohol use in teen-rated video games. So we're trying to find a confidence interval for the mean time, the mean number of seconds that we see alcohol use in teen-rated video games. So to create a 95% confidence interval, we're going to go back to T interval after we have put the data into L1. Okay, so once again, stat, edit, put your data into L1. Then we go to T interval. On the input side, we tell it to go to data instead of stats. We tell it the list is L1, frequency is 1, and our confidence level is 0.95. That should give you a confidence interval of 1.8382 to 210.66. Section 8.2, your homework assignment is out of the practice section, 38 to 48. You may not need to do all of those. Just do however much you think you need in order to get comfortable with creating confidence intervals and also interpreting confidence intervals for means when we do not have sigma. So let me know if you have any questions on this.